a solid cylinder, given radius and mass, starting from rest and rolling down an 8/10 of a meter high hill. Given the speed at the bottom of the hill, we want to find the mechanical energy lost. Okay, so this is going to be a conservation of energy problem. Okay, which factors in both rotational and translational energy. Okay, so our two states, let's draw our cylinder up at the top and then our cylinder down at the bottom. Okay, the height change was given as 0.8 meters. So we'll use the bottom location as our datum. Okay. Its velocity when it starts at rest okay, and its velocity at the bottom is 2.6. Okay. So let's write out our conservation of energy equation with several terms here. We're going to have the 1/2 mv squared at the top plus 1/2 I omega squared okay, plus mgh, and these are all we'll call them 0 or initial values. And at the bottom we're going to have 1/2 mv final squared plus 1/2 I omega final squared and an energy loss. Okay. So now it's just plugging in numbers. The only value we don't know, actually this turns out pretty easy because that velocity is 0, which means that is 0. We know the final velocity, so we can relate that to the final angular velocity here. We're given a mass and a radius, so we can calculate I. So that works out pretty easily. So let's rewrite E loss as equal to mgh0 minus 1/2 mv final squared. Okay, and let's go ahead and put in, let's calculate now, minus 1/2 I omega final squared. Okay, let's go ahead and calculate I off to the side here. I for solid cylinder, again we will give you these values in this particular exam. We would use it about the z-axis, 1/2 mr squared. Thickness doesn't matter, it's only the shape relative to the given axis. So that's 1/2 mr squared, which is 1/2 come on here, mass of 2.2 and a radius of 0.15. Okay, so that value for I comes out to be 0.02475 kilogram meters squared. Okay, omega final, okay, is the velocity final divided by the radius. The velocity final is 2.6 meters per second, and the radius is 0.15 meters. So let's see, 2.6 by 5.15, 17 1/3 radians per second. Okay. We can do those because we had all those values. Makes it a little bit easier to see what we've got here. So mass of 2.2 kilograms, gravity 9.81, H 0.8, minus 1/2 2.2 times 2.6 minus 1/2 0.02475 17.33 squared. Just a quick check of units. All these should have the same units. Kilograms, meters squared over seconds squared. Kilograms, meters, and seconds both squared. Kilograms, meters squared over seconds squared. Kilogram meter per second is a Newton, and meter, so Newton meter is a joule. So this will come out in units of joules. So let's see what that gives us here. 2.2 times 9.81 times 0.8 minus 0.5 times 2.2 times 2.6 squared minus 0.5 times 0.02475 times 17.33 squared. $6.11. Again, it's Newton meters or joules. So that's our energy loss. Key points to this problem. Just identifying the two states, writing out our conservation of energy equation, which was in a general form right there, and then just being careful with all our values. 6.11 joules energy loss.